Hello, hello everybody. This is Mr. Mulvihill here, coming at you for day 3. Oh my gosh, day 3 of our online learning. I do want to just mention a couple things for today. I'm hearing that sometimes the videos are too fast or perhaps too long. What I would recommend is that you guys really pause the video if you don't understand something or if you need to hear me say it again. You guys are in charge of your own learning. I am going to be available as much as I can on Google Classroom throughout like the normal school day. I'm going to see if I can get on this Google Hangout thing. But for right now, you're watching this note video and you're doing that and you're pausing the video trying to make sense of it. This is new stuff, so it's going to be difficult. You're going to have to pause the video when things get a little too fast, or you're going to have to email me or post in Google Classroom. Alright, so we got some not too bad today. We got a bell ringer here, and all this is in red, so all that means you have to copy everything down in red in your journal or on loose leaf paper. Maybe you did print it out, then you're fine, but if you didn't, you need to copy this stuff in red down on loose leaf paper, so that's going to take a little bit. So take some time to do that, and when you're all done, you can start the bell ringer. So I'm going to have you guys pause the video, and when you're ready, resume it to see the answers. Okay, so here is our bell ringer here. We're going to evaluate. That means find the numerical answer. So we have 5 plus 2 to the third. So remember from yesterday, that 3 means we're going to multiply 2 by itself 3 times. We still have that plus 5 there. Now we can simplify. 2 times 2 is 4. We still have that times 2 to the right, and we still have that plus 5 to the left. Then we're going to do 4 times 2 is 8, plus 5, and that will simplify to 13. 1 to the 4th plus 6 squared. Well, 1 to the 4th is going to be 1 times itself 4 times, plus 6 times 6. So that's just 1 over here, plus 36 for 6 times 6, and that'll be 37. 4 squared times 2 squared. That's going to be 4 times 4. We'll drop that down. The times 2 times 2. So that'll be 16 times 4, and that equals 64. Again, definitely important to try these without a calculator and then check with a calculator, because we got to understand these rules of exponents. We'll be learning 2 more today, but we got to know that 1 to the 4th means multiply it's 1 by itself 4 times. It's always going to mean that. Alright, let's look right here. 3 cubed minus 2. So 3 cubed is 3 times 3 times 3. And then just copy everything else down. So 3 times 3 times 3 is going to be 9 times 3 minus 2 over 5. And then we'll get 9 times 3 is 27 minus 2 over 5. That just equals 25 over 5, and that equals 5. A little trickier one there. Oh, this one's, I guess, nicer for the next one. 2 times 2 times 2 times 2. That should be 4 times 2 times 2, 8 times 2. Just bringing down these multiplication symbols. And that'll be 16. Right here, 2 to the 3 times 2. So that's 2 times 2 times 2 times 2. And hey, we just did that. That's 16. And last one here, 5 minus 3 over 7. Well, 5 minus 3 is 2 over 7. I don't really know what that is by hand. I don't know what 2 divided by 7 is, so you know what? That's my answer then, 2 over 7. That's going to come out to some crazy decimal, 2 divided by 7. So when things come out to crazy decimals, the best answer is the fraction, because it leaves it exact. This is like 0.28-ish. But you just want to leave it as a fraction there. Okay, so I hope that bell ringer went okay. There's another look at it. Key thing is, if you have something like 3 to the 4th, that means we're going to multiply 3 by itself that many times. And you can figure it out. That's the first rule that we learned. We're going to learn 2 more rules about exponents today. So, today's goal. Everything in red you're writing down. So I would create that table for yourself on loose leaf paper, and we'll get to it here. So pause the video, give yourself some time to do that. I'm going to write in green in honor of yesterday. Well, now it's going to look like Christmas colors, but alright. So, let's see. Learn 2 rules about exponents. The first rule is called the product rule. Now, if this is me, and my math teacher just said the product rule, I would think, where have I heard that word before? Product. That means multiplication. So this rule is going to have something to do with multiplication. So, let's say we have, this is when it applies. You're only allowed to use this rule when you have something like this. Say you have 3 to the 4th power times 3 to the say 7th power. So if you ever have these bases, if you remember yesterday, these are called bases. Whenever you have bases that are the same, you can use this rule. So we say bases must be the same, and we must be multiplying. This is the product rule. You can't do this rule if we're not multiplying. So notice the multiplication in between the 3's, and notice how the 3's are the same number. So that means we're allowed to use this rule. So what does this rule say? Well, it's quite simple. It says if you're multiplying 2 things with the same number, the new answer will just be 3 to the power of your exponents added together. So 3 to the 4 plus 7. So that will just turn out to be 3 to the 11th. And that's the rule. So if you ever have the same number being multiplied, you can add the exponents to get your new amount, and it will be equal. Now, who says it would that'd be equal? Here's a proof of it. If we take 3 to the 4th times 3 to the 7th, and we acted like this was the bell ringer, well, what would we do with 3 to the 4th? We'd multiply it by itself 4 times. Because that's what exponents mean. We can never forget that. And then we'll bring down that multiplication. So times 3 to the 7th. So we're going to multiply what by itself 7 times? 3 by itself. So 3 times 3 times 3. That's the third one. 1, 2, 3, 4. That was for the first. And the second one. 1, 2, 3, 4, 5, 6, 7. So we'll finish out multiplying those. Times 3 times 3 times 3 times 3. And if you look at this, we multiplied 3 by itself 11 times. And if we learned from yesterday, the opposite of multiplying, going backwards, instead of writing out, the multiplication of 3 that we did, we can put it in exponent form. So if there's 11 3's, that's 3 to the 11th. And that's the proof that this rule actually works. You wouldn't be asked to really prove this, most likely, in 8th grade, but in algebra you might. And that leads us to what this means algebraically. So if you were to see this rule algebraically, sometimes, you might not be dealing with 3's. You might be dealing with a number you don't know. So that might be like x. And say it's raised to some power you also don't know. We might call that a. And if you multiply it by itself, so x to some other exponent, b, you'll get x to the a plus b. So if you have exponents, if you have bases which are the same, you can add the exponents. All right. So that's the rule. I would say the most important part is to know this fact, how it works, and when it applies. So let's look right here at some practice. It says, decide if you can apply the product rule. If yes, just simplify and don't solve. If no, just evaluate. So evaluating is what you did on the Bell-Ringer. So let's look at the first one here. I'm going to pick out 3 to do with you, and then I'm going to let you guys try the rest. So I'm going to look at number 1 here. So 2 to the third and 2 to the second. This rule does apply because if you look, we're multiplying the same number by itself, those 2's. So what we can do is say, all right, we're going to add the exponents, 3 plus 2, and that'll be 2 to the fifth. And that's our answer. All right. Let us look at number 7. Number 7 is 5 squared to the times 2 squared. So you notice the exponents are the same, but the bases, those aren't the same. So we can't simplify this. We can't use the product rule. You can only use it if the bases are the same. So we're going to solve this just by, evaluating like the Bell-Ringer. So 5 squared is 5 times 5 times 2 squared, which is 2 times 2. Go ahead, solve that out. This will be 25. This will be 4. 25 times 4 is 100. So if you can't use the product rule, just solve it out normally. All right. If I were to try one more with you, I will try number 3. This we have 2 cubed plus 2 to the 4th. Well, they have the same base there, but we're not multiplying, so we can't use the rule. So again, we're just going to have to go about this normally, like you never learned the rules before. So that 2 times 2 times 2 over here will give us 8, plus 2 times 2 times 2. We already did that in the Bell-Ringer. That was 16. So 8 plus 16 is 24. Okay, I want you to do, if that made sense to you, try those next ones. If it didn't, I would rewatch that portion of the video and then go ahead and try the remainder ones and resume the video to see the answers coming at you in just a little bit. Okay. Number 2, you have the same base, so you should be getting 5 to the 10th when you just add those exponents there. Don't have to solve that anymore, just simplify. That's simplifying it. We only have 1 exponent now instead of 2. 3 cubed plus 3 squared. We can't use the rule here because we're adding, so we'll just do 3 times 3 times 3 for that portion. And for this portion, we'll do 3 times 3, just twice. And then 3 times 3 times 3 is 27 plus 9. That will be 36. Next one, we have 7 to the 7th power times 7 squared. Yeah, they both have the same base. That'll be 7 to the 9th. This one, yep, they have the same base, so we're multiplying. We're going to add the exponents. So you get 2 to the 5th. We're not going to multiply the exponents together. We're not going to multiply the 2's. We're definitely not going to get 2 times 2 is 4 to the 6th. We're not multiplying everything. It's very important right there. Got to follow the rules exactly how they're said. Okay. These ones down here. 8 was a little tricky. You're just going to add all these numbers up. So 4 plus 2 plus 5. That will give us 11. 3 to the 11th. 1 cubed times 3 cubed. Careful. These are different bases. Can't do the rule. So we're going to do 1 times 1 times 1 times 3 times 3 times 3. All that will just come out to 1 times